Good afternoon. Today we are starting Unit 2, talking about probability. And with probability, the symbol that we use is a P. Okay, and if you think about probability, it's really in fraction form, the number of favorable outcomes divided by the total outcomes. So for example, if I was going to roll a die, okay, what would be the probability that I would roll a 3? Well, there's only one way you can roll a 3. There are 6 numbers on a die, so your probability would be 1 out of 6. And again, most of the time we're going to leave our probabilities just in fraction form. We're not worried about reducing them, or changing them to percents or decimals. Fraction form is fine. Okay. If we said, what's the probability of rolling an even number? Okay, well, what are your possibilities? 2, 4, or 6. So now your probability improves to 3 out of 6. Okay, 50% chance. Probability of rolling a 7 would be 0 out of 6 because there's no 7 die, so you can't have a probability of 0. Probability of rolling an integer. Well, all the numbers are integers, so it's 100%. So what we're trying to show you there is that probability can be from 0 to 1, okay, from 0 to 100%. We can have probabilities of 0, probabilities of 1, and anything in between. We cannot have a probability greater than 1. So you can't tell me a probability is equal to 8 or probability is equal to 5. That's impossible. Okay. If we roll 2 die, okay, the first die has 6 outcomes, the second die has 6 outcomes. So that's 36 total outcomes. Okay. Now if we said the sum of 2, okay, what's the probability of getting a sum of 2? There's only one way it can happen. You can roll a 1 on one die and a 1 on the other die. So the probability of that happening is 1 out of 36. Okay, and if we keep continuing this pattern, what's the probability of rolling a sum of 3? Well, there's 2 ways to roll a sum of 3. So you got a 2 out of 36 chance. And what we notice here when we look at this chart is that it goes up by 1 each time. The probability of rolling a sum of 4 is 3 out of 36. And then 5 is 4 out of 36. 6 is 5 out of 36. And then it peaks. Okay, it peaks right at 7. Okay, 7 is the roll that comes up the most often. Okay, so if you think about gambling and you think about the game of craps, okay, what don't you want to roll the first time? A 7. Okay, why do they make it 7? Because that's the number that comes up the most often. And then it goes down again. Probably rolling a 8 is 5 out of 36. A 9 is 4 out of 36. 10 is 3 out of 36. 11 is 2 out of 36. And 12 is 1 out of 36. So those probabilities, okay, when we're talking about classical probabilities, we're talking about probabilities with dice and with cards and with coins. Okay, so those are some examples with dice. Now, the second thing that we want to look at is what's called the tree diagram. Okay, in a tree diagram, what it does is it shows you all of the possible outcomes. You're doing an experiment. So the experiment that we're talking about is flipping a coin twice. Okay, what are all the possible outcomes? So the reason why we call this a tree diagram is because the first time I flip this coin, I know I'm either going to get a head or I'm going to get a tail. Now, it doesn't matter what I flipped the first time, but I know when I flip the second time, it's either going to be a head or a tail. And if you did tails the first time, again, it could be heads or tails. So what we're going to have here are 4 outcomes. You could have heads the first time, heads the second time. So that's our first sample space, heads, heads. You could have heads the first time and tails the second time. Heads, tails. You could have tails first, heads second, tail, heads. Or you could have 2 tails in a row, so tails, tails. So our answers are what are our sample space. Okay, and for this particular sample space, we had 4 outcomes. Okay, there's only 4 possibilities. Now I can turn this into a probability question. I could say, what's the probability if you flip a coin 2 times that you get exactly one head? Well, exactly one head would be these 2 choices, so I have a 2 out of 4 probability. If I said, what's the probability that you are going to get 2 heads? Okay, well, there's only one possibility of that. If I said, what's the probability that you're going to get 0 heads, which is the same thing as saying tails, tails, there's a 1 out of 4 chance there. Okay. To give you another example of a tree diagram, okay, think about if you were going to have children. Okay, so you and your partner have decided that you want to have 3 children. Okay, so the first time you have a child, okay, it's going to be a boy or it's going to be a girl. Okay, we make our branches of our tree diagram. And just like the heads or tails, it doesn't matter what you have the first time. You could have a boy or a girl once again. And then if we branch off of these, because we're going to have a 3rd child, what we're going to see here is that instead of having 4 outcomes, now we're going to have 8 outcomes. And we want to kind of do this systematically so that we don't forget any of the values here. Okay, you can have a boy, and a boy. Okay, so the first sample space is having 3 boys. Then you can have a boy, and a girl. Okay, then we go boy, girl, boy. And then boy, girl, girl. So those are the 4 possibilities when you have a boy first. Now there's also going to be 4 possibilities when you have a girl first. So we're going to do girl, boy, boy. You're going to have girl, boy, girl. You're going to have 2 girls. And then you finally get your son. And then the last possibility is the reason why I stopped at 2 girls, because I knew I would have the trifecta of 3 girls, and that would not be good having 4 women in the house. So 3 women is enough. So with 3 children, you have 8 possibilities. So again, when they ask you what is your sample space, okay, those are all the possibilities of having 8 children. Those are all the different outcomes we could have. And again, if I said to you, what's the probability that you're going to have 3 boys? Okay, there's only one case there where you have 3 boys. Okay, 1 out of the 8 cases. Probability of having 2 boys, right there, and right there, 3 out of 8. So the probability of 1 boy is also going to be 3 out of 8. Right there, and right there. And the probability that you don't have any boys, like we said, is 1 out of 8. And again, that sum adds up to 8 out of 8. So that's how we use a tree diagram to illustrate a small sample set. Okay, now if we had like 64 outcomes, we probably wouldn't use a tree diagram, it'd just be too much. But when we want to get a small amount, okay, and lay that out, tree diagram shows us a good way to see all the outcomes of a probability experiment. All right, that is it for today. Good luck with the exercises.